This is the Almost Timely newsletter for the week of January 21st, 2024. Content authenticity statement: 98% of this week's newsletter was generated by me, the human. There is some AI-generated artwork in the opening piece, which you may or may not find revolting. What's on my mind this week? Prompt engineering and latent space. This week, let's talk about prompt engineering and latent space. This is a concept that I'm working on for our upcoming Advanced Prompt Engineering course, which is going to be a supplement to the Generative AI for Marketers course, which if you haven't taken it, please do go take it. Just updated it about a week and a half ago with some new stuff on the use of various public relations techniques for getting listed in language models. There are a ton of different prompting strategies out there on the internet, and a gazillion people hawking their secret prompt recipes for whatever amount of money that they're charging us. I want $15 for this, $25 for this super secret prompt. How good are these prompts? Are they worth spending money on? What about all the prompts that people are sharing on LinkedIn and other social networks? Here's my ChatGPT Ultimate Prompt Guide. Well, to answer this question, we have to start with latent space. What the heck is latent space? Latent space is the encoded knowledge of language in a large language model or images in a diffusion model. It is the stored patterns of data that captures relationships and, when prompted, reconstructs something from those patterns, reconstructs language for a language model, reconstructs an image from the image models, from diffusion models. Let me give this in tangible terms, because there's a lot of technical terms. Suppose you wanted to build a pizza model, an AI that could generate pizza. You would take photo after photo of pizza after pizza, noting how all the toppings look. You look at the relationships between toppings and cheese, where the toppings are spread, how dense they are, whether they're on top of the cheese or under the cheese, what kind of cheese was used, how much sauce was used. You'd measure this from every pizza you could get your hands on all over the planet. And when you were done, you'd have a database of measurements about pizza, statistical relationships about all the things on pizza. You'd have things like the average number of slices of pepperoni, or how close the jalapenos are to the onions, or how much pineapple belongs on a pizza. Then, when someone came to you and said, hey, I want a pepperoni and pineapple pizza, you would go into your huge catalog of statistics, right, and query it. You'd ask it for pineapple and pepperoni. It would give you some averaged answers, some averaged data back about how much of each belongs on a pizza and the layout and all that stuff. And it would essentially make you a recipe, and then you go and bake that recipe with those directions. That database of statistics is the latent space. It's an understanding of patterns that you can use to generate new outputs. This, by the way, is why the issue of copyright is so tricky with generative AI. The author's original works, whether they're words or images, they are not in the model. Statistical descriptions of an author's works are, but just like our pizza database doesn't contain any actual pizza, a language model or a diffusion model contains no actual original works, just statistical representations of the elements that make up those works. So, the latent space is basically a statistical database. Now, what does this have to do with prompting? Well, with language models especially, all language models are trained from very large text databases like Common Crawl, Archive, Stack Exchange, Wikipedia, Project Gutenberg, etc. Those big databases contain varying amounts of knowledge on a significant number of topics, right? And the quality of the knowledge varies wildly. Just because it's in Wikipedia doesn't make it right, and just because it's on Blogspot or Reddit doesn't make it wrong. When we write a prompt for a language model, our prompt is ingested by the model and matched up against all the stuff in its latent space, looking for things that are similar, kind of looking at its database of statistics, and then it returns a pile of statistics that then get reassembled as words or images, just like a recipe is ingested by a chef's brain and performed by the chef into food, right, into a dish. If we prompt a language model and we get a dissatisfactory response, it's very likely the prompt we used was insufficient when it comes to the very biggest language models, but it is equally possible and grows more probable the smaller a model gets, that the latent space of a model may not have enough information about what we're prompting it about. What happens in that case? The model hallucinates, which is tech speak for drawing on the next set of likely probabilities, even if especially if they are factually wrong. A model that doesn't know the exact specifics of a prompt because the knowledge isn't in its latent space will choose the next closest match. Right? That's how these models work. You and I, interpret that as a mistake, but the model is functioning correctly. It's actually doing what it's supposed to be doing. It's returning statistical probabilities. It's just that the knowledge isn't in the latent space. For example, in the early days of language models, when they were trained on relatively small amounts of data, not like today, and not fine-tuned to follow instructions based on, millions of examples, you could ask a model who was president of the United States in 1492. Now, we know from history and basic reasoning capabilities that there was no president of the United States in 1492 because there was no United States in 1492. But a model doesn't reason. It just assembles probabilities. The President of the United States, that phrase indicates a person. It's typically a prominent person, unless you were, President Taylor or President Van Buren, names no one seems to remember. 1492 is associated, for good or ill, with a prominent person, Christopher Columbus. In the absence of factually correct statistical matches, early language models replied that Christopher Columbus was President of the United States in 1492. That is statistically a sensible answer. The language model is working correctly, even though the answer is factually wrong. That's hallucination. A key part of advanced prompt engineering is knowing the limitations of a language model's space, of that latent space, knowing what's in the database. You have to assess the latent space for a given topic to know what it knows on that topic, assuming, if it's important enough for you to want to use generative AI in the first place, you want to know what's in its database before you can start constructing prompts. Otherwise, you will run the risk of prompting it for things it doesn't know well, and the answers you get back will have a high chance of hallucination. They will be statistically correct under the hood, but they'll be factually wrong from a reasoning standpoint. Going back to our pizza analogy, suppose you gave your pizza chef a request for a pizza with ham and pineapple, but let's say the chef has never heard of pineapple. Chef knows that from our description, a pineapple is a tropical fruit, a sweet fruit, and a yellow fruit. So chef makes us a pizza with their best guess, and they make a ham and banana pizza. You can see how, from a descriptive characteristics perspective, a statistics perspective in a way, pineapple and banana might be thought of similarly, right? Both tropical fruits, both yellow, both sweet, but no, if you think pineapple doesn't belong on pizza, banana really doesn't belong on pizza. But that's a concrete example of prompting a model for something that isn't in its latent space. It isn't in the database of knowledge that it has, and it's substituting the next closest thing that seems rational and logical, right? Tropical fruit, yellow, sweet. Not the same thing. Very much not the same thing. So how do you assess a model's latent space? By asking it what it knows on a topic, especially deep into the topic. And that requires you to have subject matter expertise, to know the boundaries, right? If you know the topic well, you can ascertain just how deep a model's knowledge goes before it runs out of knowledge and starts to hallucinate. And that tells you, here's what the model really knows. For example, I went to a chatbot arena and I started with a fairly technical prompt. I said, describe the key characteristics of the SARS-CoV-2 virus JN1 clade in terms of the L455S mutation, which is a mutation on the protein spike of the SARS virus that causes COVID-19. It's the current variant that is very prominent right now. When I ran this in Chatbot Arena, one model said JN1's parent lineage is BA2.86. Another model said JN1 is also known as BA2.75. The second model's response is factually incorrect. It sounds good. It's statistically relevant from a data perspective because they're both strains of COVID, but it's factually wrong. JN1 comes from BA2.86. The model hallucinated, meaning that its latent space doesn't know about what the JN1 clade actually is. That's how you evaluate a model's latent space. You say, oh, you get deep, deep, deep into the weeds until you find the point where it stops knowing things and starts making things up. And that's when you know there's the edge, right? We can't go further on that, on asking a model to create things or generate things once we're past that boundary. Now, what do you do when you evaluate a model and you find those limitations? Well, latent space is basically the database that a model draws from. So if you find out a model lacks knowledge on a topic, a deep level of knowledge, you have to provide it. You have to provide that knowledge. And that means incorporating the knowledge either in the prompt itself. Some models can take huge prompts as inputs, or through uploading data and documents. Like in ChatGPT and in custom GPTs, you can just upload attachments. By providing the data you want the model to use, you're effectively increasing the latent space of the model. You're putting more probabilities in its database, and thus you're going to reduce the likelihood that it's going to hallucinate on you. This is the key part that prompt engineering guides overlook. No matter how good your prompt is, if the model does not have knowledge of what you're prompting, your prompt isn't going to perform well. If a model does not have knowledge of what you're prompting, your prompt will not perform well. Period. End of story. It's like asking a chef to cook with ingredients they don't know. You can be incredibly clear in your instructions, but if a chef has no knowledge of what you're asking, like, hey, make a dish with starfruit. You never heard of starfruit? Like, make it up, right? You're never going to get a satisfactory result. Right? You just won't. The chef won't be able to do it. To have a chef cook with starfruit, in this example, you would have to provide that ingredient to the chef and maybe even make them taste it a couple of times so they know how it tastes and how to use it. Similarly with a language model, if a language model does not know the technical intricacies of your topic, you have to provide those ingredients. You have to increase its latent space. This is also why it's important when you're doing prompt engineering and prompt governance especially. This is why prompts should be associated with specific models. The prompt I used above would be best used in models that know what the JN1 clade is, right? And that prompt should not be used in models that are unaware of it until they're augmented with new information. Now, for common older topics like, management skills, leadership skills, personal finance, where there's a large amount of basic knowledge that already exists, a prompt that you write about that, like, let's write some stuff about leadership strategies, that prompt's going to be pretty portable. It's probably going to be able to work in most major language models. But the deeper a dive you need to do on a specific topic, the more careful and specific you're going to need about which model to use with prompts on that topic and which supplementary data you're going to have to provide no matter what, right? If you are a COVID researcher and you are looking at papers that are coming out now, today, and all these other models stop their knowledge in April of 2023, you have 10 months of data you have to provide to models so that it expands their knowledge, expands the latent space of what they know about. It's just an example. So that's the secret to prompt engineering, one of many. Right? You have to know the limits of the model you're working with in order to make sure that your prompts are a good fit for it. And if the model does not have that knowledge, you have to provide it as part of the prompting process. Otherwise, you're just going to get bad results. Finally, it turns out I ran a poll for fun. No one likes the idea of banana on pizza, so I'm not thrilled with the idea either. But I ran a poll on Threads, and 100% of respondents said no, banana does not belong on pizza. All right, what else happened this week? I had a couple of really useful articles, one of which, the one I recommend you pay attention to, is the legality of works in custom GPTs. I had said, and I had asked 3 friends of mine who are lawyers, can you load a copyrighted work into a custom GPT? And all 3 lawyers said, no, you cannot do that. Not with you're infringing on copyright by essentially making a derivative work. So go watch the video. It explains everything, and I have some links to the lawyers if you want to talk to them about their practices. Also talked about the difference between retrieval, augmented generation, and fine-tuning. On the live stream this week, we looked at the use of generative AI with analytics, using it for analytics purposes. And in last week's podcast, the Trust Insights podcast, I talked about unlocking workforce potential with generative AI based on a Gartner survey that we looked at. That Katie and I had some pretty strong disagreements about. Not uncivil, but just from a perspective of what AI is capable of. It's capable of quite a bit more than people think. All right, let's talk about jobs. What jobs do we have this week? Data platform engineer at Clinician Nexus, deep learning scientist of generative AI at Barrington James, direct marketing lead at Electrolux Group, director of content marketing at Outreach, e-commerce analyst at Henry Schein Dental, e-commerce media specialist at Electrolux Group, generative AI engineer at Smart IT Frame, logic monitor, something, I don't know what that means, senior product engineer of EHR and generative AI at a health tech startup, and specialist of communications direct at Commerce Bank AG in Germany. In other news this week, social media, a lot of stuff, people talking about social media publishing this week. Everyone's trying to figure out their scheduling and publishing stuff. I do use Agorapulse for my scheduling. I enjoy it, so be sure to check that out. There's a link in the newsletter if you want to learn more about it. Content clusters and why you need them. Google responded to claims of garbage AI content showing up in Google News, and Google is saying, yeah, we know about it. The person who was highlighting it was looking at the news chronologically versus using the built-in AI sorter, but they said there is room for improvement there. Also this week, Mark Zuckerberg said that Meta is pushing hard to lead the AI future. He had a really interesting video about what they're doing. They're bringing on the equivalent of 600,000 H1 GPUs, which is about $2.8 billion worth of hardware to train AI. It consumes about 420 megawatts of power, which is the power plant of a mid-sized city. But Llama 3, the Llama 3 model is supposed to be coming out sometime this year and probably will be an improvement over Llama 2, which will be very interesting. Fairly Trained launched to certify AI tools trained on licensed data, which is interesting, and OpenAI is still trying to pursue its dreams of a chip fabrication plant to make their own hardware, which is also interesting. That's kind of an interesting choice. Also, a piece in The Atlantic about the internet is being ruined by bloated junk, which, again, not a surprise. And The Surprising Secret to Standout Ideas by my friend Tamsin Webster was a really interesting read. Give that one a few moments of your time. Upcoming travel, the Tourism Industry Association of Alberta in Edmonton next month, followed by the Independent Consortium of Booksellers in Denver. I'll be at that, followed by Social Media Marketing World in San Diego, and the Marketing Profs AI Series, which is virtual. That'll be in March. The Australian Food and Grocery Council in Melbourne in May, and the Marketing AI Conference in Cleveland in September, and the Marketing Profs B2B Forum in October. So those are the shows that are signed right now, and there's 4 more that we're currently trying to work out the bookings on and stuff. If you've got a show coming up, a conference coming up that you would like me to speak at, there's some link in the newsletter. Please let me know. That's going to do it for this week. Thank you, as always, for being here, for listening, for watching, for however you consume the newsletter. I appreciate your time, and I hope you got something useful out of it. I'll talk to you next time. If you enjoyed this video, please hit the like button. Subscribe to my channel if you haven't already. And if you want to know when new videos are available, hit the bell button to be notified as soon as new content is live.